The topic of this video lesson is how to find a reference angle. So let's start by defining a reference angle. If we have theta is an angle in standard position, its reference angle theta prime is the acute angle formed by the terminal side of theta and the horizontal axis. If theta is an acute angle, then there is no need to find a reference angle. So let me talk about that here. So we have theta. Well, the reference angle, theta prime, is the acute angle formed by the terminal side of theta and the horizontal axis. Well, what is the horizontal axis? That is just the x-axis, right? Well, the terminal side of theta is here, and the horizontal axis is here. So the reference angle is going to be this angle right here. So that is theta prime. Well, how can I find that mathematically? Well, we can either think of it in terms of degrees or in terms of radians. But notice here that we are theta prime short from being a total of 180 degrees or pi radians. So theta prime is going to be the difference between 180 degrees and theta, or we can put that in terms of radians. We could say pi minus theta. Now if we have our angle that extends beyond the 180 degree mark, so we have theta here, our reference angle is still the acute angle that's formed by the horizontal axis and the terminal side. So our reference angle here is still going to be between the horizontal axis and the terminal side of the angle. So this is going to be our reference angle here, theta prime. Well, what is theta prime? Theta prime is how far we extended beyond 180 degrees. So this time we're going to define theta prime as theta minus 180 degrees, or in terms of radians it would be theta minus pi radians. Okay, so we're looking at really what's the difference between the angle and the 180 degree mark, either if we don't go quite all the way there or if we go beyond it. Now what happens if we go around to the fourth quadrant? So we're looking at if the terminal side is in the second quadrant, the terminal side is in the third quadrant, now the terminal side is in the fourth quadrant. So if our angle theta is here, well, theta prime is again the acute angle formed by the terminal side and the horizontal axis. So our terminal angle is going to be, or not terminal angle, I'm sorry, reference angle is going to be here. That's theta prime. Well, what is that in this case? Yeah, it's how far we are from the full revolution of the circle, that is 360 degrees or 2 pi radians. So here we could define theta prime to be 360 degrees minus theta, or in terms of radians it would be 2 pi minus theta. Okay? Now I'm going to explain where the reference angle is needed in just a little bit, but right now we're just getting practice at what is the reference angle. So the reference angle is, again, the acute angle formed between the terminal side of theta and the x-axis. Always the x-axis. So let's look at some examples. If we want to find the reference angle for the following angles, we're going to sketch both angles in standard position. So we have theta is equal to 225 degrees. So what would we have? Well, you may want to get out your unit circle and look at that, but we can think of this. 225 degrees. Let's think. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees. So 225 is going to be somewhere in the third quadrant, right? So here's our 225 degree angle. And again, it has a initial side on the x-axis there. Well, what is the reference angle in this case? Yeah, our reference angle is going to be this much, right? It is the angle formed by the terminal side and the horizontal axis. So this is, we've extended beyond 180 and we're in terms of degrees, so our reference angle is going to be 225 degrees minus 180 degrees, which is 45 degrees. So if we want to see our reference angle in standard position, our reference angle in standard position is here. That would be a 45 degree angle. Okay. Now, what about 5 pi over 3? So you've got to get in terms of thinking about radians again. Well, we know 5 pi over 3 is it greater than 180, less than 180? What would you say? Yeah, 5 pi over 3 is really 1 2/3 pi. Well, 1 pi is here. 2/3 means we're going to go 2/3 of the way around. Okay, you can think of it in terms of 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. So it has a terminal side that's in the fourth quadrant. So the reference angle is the acute angle formed between the terminal side and the horizontal axis, so it is going to be what? Well, now we're in terms of radians, so it's how short are we from making a full revolution. So theta prime would be, a full revolution is 2 pi minus 5 pi over 3. Well, 2 pi is really 6 pi over 3 minus 5 pi over 3. You could have done this without having to show the work, and that's fine. So it would be pi over 3. So the reference angle is pi over 3. That in standard form would be here. Now what about negative 292? Okay, so now we're rotating in the clockwise direction. So we know that we have what? Negative 90, negative 180, negative 270 to negative 292. Okay. So what is our acute angle that we need? Yeah, theta prime now is how far are we from going a full revolution, that is to go from 360 degrees. So theta prime in this case would be 360 minus 292 degrees. Which is what? Of course, I forgot to bring my calculator, but that's okay. So we would have 8, 15, so 68 degrees. Yeah, 68 degrees. So the reference angle in standard position would be there. Now what about theta is negative 1.8? Well, now we're in terms of radians, right? Negative 1.8 with no degree symbol is radians. So we've got to think about where does negative 1.8 lie with a terminal side. Well, if we think in terms of pi, if this is negative pi over 2, negative pi, well, we know negative pi is negative 3.14, right? This is negative pi over 2. If we divide pi by 2, we get a negative 1.57 roughly. So negative 1.8 is going to have a terminal side in quadrant 3. Okay? Well, then the reference angle is going to be what? Yeah, we got to figure out how far are we from pi, making a complete revolution. So we could do pi minus 1.8. So pi minus 1.8 is going to be approximately 1.34. Now, let me mention one thing before I leave this. Whenever you have a negative angle, it's sometimes confusing as to which direction you've got to think about subtracting from 260 or 2 pi or whatever it is, 360 or 2 pi. What you can do is think about a positive angle that has that same terminal side. So instead of thinking of that as negative 292, you could think about, well, what's a positive angle that shares this terminal side? And that would be a 68 degree angle, right? Because they would have the same terminal side, and that would make up the full revolution. And then if you think in terms of the 68 degree angle, we don't need a reference angle for that. That would just be 68 degrees. For the negative 1 pi over 8, what we could do is say, what is 2 pi minus 1.8? So in terms of this one being a negative 1.57, the one that shares its terminal side would be 2 pi minus 1.8, which is 4.48 roughly. And then we could subtract 4.48, subtract pi from that, and that would give you another way to think about the reference angle. So you could also do 4.48 minus pi and get 1.34. So if you want to think of it in terms of the negative angle, or find a co-terminal angle that is positive and then subtract off the value that you need to find the reference angle. Either way is appropriate. Okay? So if you have any questions, please don't hesitate to contact me. Thanks.